Hello and welcome to episode number 22 of the series on how to create a chess game with ReactJS. In this episode we are going to add indicators for the possible moves for the pawn. If we pick up this pawn right here, we see that we can move 1 or 2 spaces. If we move 2 spaces and we pick it up again, we see that we can only move 1 space. So if you want to know how to create this yourself, enjoy this video. To start off, we are going to open up the referee. And we are going to add a new method which will return all the valid moves. We are going to name it GetValidMoves, and it will return an array or a list of positions. So we're going to say colon position array. For now this is empty, but what we want to return in the end is an array of positions. In order to determine which positions are valid, we need to know 2 things. Those 2 things are, first off, the piece. Which piece are we getting the positions for? And the second thing is, what is the board state? We need to know the board state that the piece is in. We are going to add those as parameters to our method. So now that we know the piece and we also have the board state, we want to make a switch statement for the piece type, just like we did up here, so that we can separate the logic for all the pieces. For now, we are going to implement the logic for the pawn. So we say case piece type dot pawn, and then we want to return something. Return the moves, and then we also have a default which will return an empty array. We don't need this return anymore. And the next thing to do is return something in the pawn statement. Instead of writing the logic for getting all the pawn moves right here, we are going to put it in the pawn rules file. If we open up the pawn rules file, we see that we already have one method here from before, which determines if a pawn move is legal. We want to extend this with another method, which will get all the possible pawn moves for a given piece. So we say export const get possible moves is equal to, and then the method, which parameters do we need? We need our piece, and we need the board state, which is a piece array. What does this method return? It returns the same as the referee method, so this will be a position array or list. And then we want to write a body like so and return an empty array for now. Now we have the setup for getting the possible moves for a pawn. We can add this to our referee. So right here, we don't want to return an empty array, but instead we want to return get possible moves, and then we need to pass in the piece and the board state. And now that I think of it, it might be better to give this a specific name, because right now if we go to the import statement of GetPossibleMoves, we see that it is imported from /rules. If we also name this method the same in the queen and the rook, we will get some naming conflicts. So let's name this GetPossiblePawnMoves. Let's also alter the import right here, and in our pawnrules.ts we also say GetPossiblePawnMoves. Now that we have the place where we want to write the code, we can start by implementing the logic. Instead of returning an empty array, we are going to define an array of possible moves, which is a position array is equal to empty, and then we want to return the possible moves at the end. Gradually we are going to add moves to this array. So first of all, a piece or a pawn in this case can move up. It always can move 1 position up. It can also move 2 positions if it's on the special row, which is the 6th row, and if an enemy is in front of it, it cannot move up at all. Same goes for an ally. So, for example, if this horse is in front of our pawn, it cannot move up either. Before we know which direction the pawn moves, we need to know the pawn direction, which is up here. We can just copy and paste that right here. So we say pawn direction is equal to, if it is our piece, so if it is a white piece, it will be 1, so it moves up, I think. And if it is a black piece, it will move down, so it will be -1. So now that we know the pawn direction, we can start writing the logic for checking if the tile head is free. So right here, we say if tile is occupied, and then we want to pass in a position. So the position will be the position of our piece, and then -1 or +1 for the y-axis. We are also going to rename piece to pawn, because the current piece is a pawn. Then right here, we want to put in the position, which will be x is pawn.position.x, and y is equal to pawn.position.y plus pawn direction, like so. And then we need to pass in a second parameter, which will be the board state. So I'm going to wrap this up in a couple of lines right here. The first parameter is the position, and then the second parameter here is the board state. So if this tile is occupied, then we go into the if statement. What we want to do is we want to invert this. So instead of saying if this tile is occupied, we want to check if this tile is not occupied. So if this tile is not occupied, we want to add the position of the tile to the possible moves. So we say possible moves.push, and then we want to push a new position, which will be pawn.position.x, and then pawn.position.y plus pawn direction. And we don't need to forget the x and the y. Now that we have our first possible move, we want to see it on the screen. We're going to save up this file, and then we are going to open up the constants.ts. In our constants, we want to modify the piece, the interface for the piece. We want to add another property to it, which will be possible moves. This can be empty or, well, in this case, null. And this will be a position array, like so. We can save that up, and now every piece has another attribute, which will be possible moves. Okay, so the piece has an attribute, possible moves. We already have the logic for generating one possible move for a pawn. All that's left to do is setting those possible moves to the pieces and then showing them on the screen. For setting the possible moves, we are going to open up our chessboard, and for a moment, let's think when we want to update our possible moves. So, do we want to do that right now, when we have the whole board? I think that we want to do it when we grab a piece. So say, for example, if I grab this pawn right here, then I want to know which possible moves the pawn has. Same goes if I take this horse. I only want to know the possible moves from this horse. So we don't need to calculate all the possible moves for all the pieces all the time. We only need to calculate it for the piece which we are currently holding. When we grab a piece, the method that gets executed is the grabPiece method or grabPiece function. So inside of here, when we enter this function, we want to calculate the possible moves for the piece that we are currently grabbing. In order to do that, we're going to say set pieces, and then inside of this method, we want to set our pieces. We also want to have a reference to the current pieces. So right here, we say current pieces, and this will return an array of the new pieces. So for now we can return the current pieces, which is fine, but this is exactly the same as, well, the current pieces. This doesn't have the new possible moves inside of it yet. So to add the possible moves for the piece that we are handling right now, we're going to say current pieces.map p, and then right here we want to alter the possible moves. Let's set it to an empty array right now, and then we want to return p. So to break it down, we are updating our pieces right here. We have a reference to the previous value, which was in the pieces state. We want to return that value, the current pieces, but before we do that, we map the value to another value. So in this case, we are not changing the type because we are still returning an array of pieces, but we are enhancing the array by adding the possible moves for the piece. So right now we are setting all the pieces to an empty array, and then we return the piece. But instead of setting it to an empty array, we want to use the referee.getValidMoves, and then we pass in the piece as our current piece, and then the board state, which will be the current pieces. So if we save this up and refresh the page, nothing will happen yet because we are not doing anything with the possible moves yet. Alright, so now that we have the possible moves in our pieces, what we want to do is we want to refactor this to a specific method, to its own method, because it is not the responsibility for the grep piece to update the valid moves. Right here, we're going to create a new function, update valid moves, and this function right here will execute this piece of code. We can put it right here, and then in the grep piece method, we are going to say update valid moves, like so. It's exactly the same as before, at least it works exactly the same, but now we have refactored this piece of code to its own function. Now that we have set the possible moves for the piece, we want to render them on the screen. So we scroll down to the, let's see, where is it? To the board right here. Here we push the tiles. Here we want to put the logic for determining if a tile is a possible move or not. We want to know the current piece that we are dragging. So we say let current piece is equal to pieces, and then find. And we want to find the piece that has the same position as the grab position, like so. So now we have the current piece right here. Next, we want to add a new variable, which will be the highlight. Highlight will be equal to current piece dot possible moves or available moves. If this is null, then we want to say that it is false. If it is not null, we want to say, all right, then we want to set it equal to current piece dot possible moves dot sum, and then we want to check if some, or well, actually any move has the same position as the current location that we are in for the for each loop. X will be equal to y, and y will be equal to j, or x will be equal to I, and y will be equal to j. So right here we have the, well, it's a pretty long statement actually, but right here we have, okay, is the possible moves from the current piece null? If it is not null, we want to check if the position of the tile is in the possible moves. If it is null, we want to say that the highlight will be false. Now that we have the highlight, we want to add the highlight to the tile. So we say highlight is equal to highlight. And we are also going to add this as a parameter to the tile right here. So here we say highlight boolean. And then we also expect a highlight right here. Now, depending on whether the highlight is true or false, we want to alter the class name. So first of all, right here, we want to create a new const class name, which will be a string, is equal to an array. And this array will contain the tile string, and it will also contain the, let's put it a little bit more forward, the, let's see, number, because if the number is modulus 2, or if the number modulus 2 is 0, then we want to say, okay, this will be a black tile. If it is not modulus 2, so if we say number modulus 2 is not equal to 0, then it will be a white tile, like so. And then finally, we are going to add one more statement, which will not be number. It will be highlight. And if highlight is true, then we want to add the class name tile highlight, like so. This is an array, and we only want to filter the statements which are true. So we say filter boolean, and then we want to join all the filtered elements of this array by an empty string, or not an empty string, a space. So we say dot join and then space as a character. So now that we have this class name, we can replace this with our class name, like so, and then this one as well, like so. And let's see, what we can also do, I think, is we can remove the if-else statements. So we now only return one type of piece. So let's hope this all works out. We're going to do this, and let's organize it a little bit more. Okay, so now we can see the class name a little bit better. And let's see, this still works, this still works, and this still works, which is great. We also have added the highlight class, but we don't see it yet. But before we are going to add that, we are going to look at this piece of code right here one more time. We have a constant named class name. So this is the variable class name, which is a string. That means that it is one string, not a list of strings. It is just one string, which might confuse you because right here we pass in an array of strings. So the first string will be tile. Tile is just a plain string, and that's it, nothing more to say. The second string that we pass in consists of two properties, or two elements. The first one is a check, which is, okay, is number modulus 2 0? Okay, if that's true, then we want to return the black tile. Okay, the next one is number modulus 2 not equal to 0? Is this true? Then we want to return white tile. Which means if our number is 1, so let's say number is equal to 1, this one will be true, and this one will be false. If we say number is 2, this one will be true, and this one will be false. So as you can see, only one of the two statements can be true, which means we never have a black and white tile. We only have a black or white tile. To finish it up, we have the highlight. So if the highlight is true, we say, okay, then we want the string tile highlight. But how can we create one string from those booleans and strings and AND operators? Well, we do that with the filter. So here we filter with the boolean filter. And what the boolean filter does is it evaluates all the elements in the array. So the first element is a string. And it looks, okay, is this string true? Well, the string is filled, so it's true. The second element in the array is this. Say, for example, we have our example of number is equal to 1. Then we have 1 modulus 2 is equal to 0, which is false. So the left operand of the statement is false, which means that this whole statement will be false as well, because we use an AND operator. And if this is false, it won't pass the filter of the boolean. So that means that this one won't go through. Well, then we come right here. If our number is 1, this one will be true. And if this left operand is true, this right operand will also be true. And by the way, right here, the right operand is also true. but because the left operand is not true, it won't get added to the, or it won't pass through the filter. And finally, we have the same for the highlight. If the highlight is false, it doesn't matter what the right operand is. If this is false, then it will never pass the filter. If this is true, however, and well, this is always true, then it will pass. So then we are left with a couple of strings, and then we want to join them together by a space. That is what we are finally putting inside of our class name right here. Great. So now that is off the charts, we are going to open up the chessboard.css, and we are going to create a new class, which will be highlighted tile. I think that's what it was named, right? Tile highlight. Well, let's copy this over, paste right here, and now we can style our tile. All right, so before we are going to style it, we first want to say that this will be a before element. And in order to see a before element, we need to set the content to something. In this case, it will be a space. Now that we have the content, we can give it a certain width, which say for example is 10 pixels, and the height, which is also 10 pixels. If we save this up and this one as well, and refresh the page, we don't see anything yet. And that is probably because we don't have a background color yet. So let's add a background color of black to it. And now that we save it up, we can see that there is a dot appearing on the screen. So if I pick up the spawn, we see the dot right there. If I pick up this spawn, we see the dot in front of this spawn. If we pick up this one, we see a dot right here. Well, let's say we move this one up here, and we take this spawn and we grab it again. We don't see the dot anymore, and that is because it cannot move forward. So the dot only appears if we can move to that location. Instead of making it fully black, we are going to say RGBA 0000.2, like so. So it's a little bit more opacity, or a little bit more faint. And then we want to make it a bit bigger, like so, maybe even 24 pixels. Great. And we also want to give it a border radius of 50%, like so. And then we have a nice clean circle. Amazing. So now that we have this, we have the first possible move for the pawn ready. One more thing I would like to add is that we don't want to see this dot when we aren't dragging our pawn. So the moment we let go of this pawn, we want to reset the possible moves, because we are not clicking anything. So in our chessboard right here, we are going to go to the function that's get executed when we drop the piece, which is right here. And if we scroll down, we see that we have an active piece which is being set to null. So instead of adding some new logic, what we can also do is we can scroll down to here. So right here, we say active piece is not equal to undefined, or null in this case. If it is not equal to null, then we say, okay, the current piece is this piece right here. And if it is null, oh, we didn't want to do that. We want to return undefined. So if we save this up and refresh the page, we can grab a piece, and we see that we see the dot, and when we let go of the piece, the dot is gone. Same goes for this piece. If we let go, the dot is gone. So now we have a pawn, and also a possible move for the pawn, which is moving straight ahead. If we put another piece in front of it, we see that the dot is not visible anymore. So it only shows the dot when we can move in that location. To finish it off, we are going to add one more possible move for the pawn, which will be the first move of the pawn. Then the pawn can move 2 tiles at once. So in our pawn rules right here, we want to say, okay, if this tile is not occupied, then we want to push this move. Instead of just pushing this move, we are going to add a little bit more logic to this function, or to this statement. So if this tile is not occupied, and then we want to check and we are in the special row. So I think we already had it right here. Yes, so we have the special row. We are just going to copy over this to here. We might want to create or put this logic in one place, but for now it's fine. Let's see if the piece or the pawn dot position dot y is equal to special row, and we need to use 3 equals. If it is equal to the special row and the special row is empty, then we want to do something. Yeah, okay, so if it is equal to special row and the tile is not occupied, let's see, x pawn position dot position actually is the same as this one. And we also need to pass the board state, like so. Let's see if tile is not occupied at this position. And instead of saying pawn direction, we say pawn direction times 2, because we are moving 2 tiles. Then we also want to add the position to the possible moves. So we say push, and then we can just copy over this one right here. We're going to put it right here, and then we say times 2. Let's see, we do need to write this bracket right here. And if we save this up, refresh the page, and pick a piece, we see that we have 2 dots, but only the first time. Also, if there is a move or a piece in front of it, we cannot move 2 tiles. We can only see the first dot. And if there is a piece directly in front of it, we also cannot jump over it. So now we have the logic for moving 2 spaces at once as well. So right here, we check if the tile in front of us is not occupied, then that is a possible move. But if we are in the special row, which means we haven't moved at all yet, and the tile in front of the tile that we were checking, so 2 tiles ahead, is also not occupied, then we can move to there as well. Alright, that was it for this episode. I want to thank you for watching. I hope you could follow along. Please leave a like, subscribe, and I'll see you in the next episode. Bye!